Anchors and mooring systems have existed as long as floating objects have been anchored at sea. The purpose of the mooring system is to maintain the position of the anchored object within given tolerances. Conventional methods of mooring have involved the use of heavy weights for anchors, clumps and chain. The reasoning being, the heavier the anchor and chain, the better the holding power. The Stingray high-performance anchor was developed on the premise that good design will outperform dead weight and represents the culmination of a great deal of research and development. The concept that the best results for an anchor come from increased penetration and fluke area has resulted in an anchor which delivers exceptional performance at a weight not previously thought possible. Stingray anchors penetrate much quicker than any other conventional anchor and have the largest fluke area of any anchor commercially available today. The result is an anchor that delivers a performance to cost ratio that other anchors find extremely difficult to match. In this video, we will be comparing the relative performance of a number of anchors commonly used in the pearling and aquaculture industries. These include the Hall stockless, a hinged fluke ship's anchor, first developed in 1821. The Danforth, another hinged fluke ship's type anchor, first put into service in 1939. The DMS 55, a fixed fluke anchor built for aquaculture use, and the DMS 300, a single-sided hinged fluke anchor, again built specifically for aquaculture applications. And the first type of anchor ever used, the clump weight. The weights of anchors vary, but each can be used to establish holding power efficiencies, which is the ratio of holding power to weight. This ratio is universally accepted as the best method by which to compare anchor efficiencies. In the interests of fairness and for a more accurate comparison of the anchor types and their specific performance capabilities, identical tackle has been used for the purposes of applying the load. The load application rate is the same for all anchors. Each anchor will be pulled to its maximum holding power, and the drag distance and penetration will be measured. The holding power will be measured in kilograms by use of an electronic load cell calibrated to Australian standards. The first anchor tested was the 28 kilogram Danforth. As the load is applied, the anchor drags for a while with only a small resistance. Then, after 1 metre, the anchor stands up on its toes to begin the burial process. The holding power has reached 140 kilograms and by 2 metres has reached 420 kilograms. After 3 metres, the load is increased to 550 kilos and the maximum of 570 kilos is reached after 4.5 metres. The anchor, however, becomes unstable and rolls out. There is considerable disturbance to the soil and no real penetration has occurred. The 60 kilogram DMS 55 starts to penetrate quickly, and after 1 metre, the holding power has reached 1,060 kilograms. The anchor does not appear stable during burial. The load continues to increase until after 2 metres, it has reached 1,670 kilograms. The load then starts to decrease dramatically, and by the 3 metre mark, the anchor is rolling out. The anchor continues to drag at a load of 800 kilos. The soil is considerably disturbed. Penetration varies as the anchor changes attitude during dragging, resulting in one of the fluke extremities being damaged under load. The 180 kilogram Hall's anchor begins dragging when the load is applied, and after 1 metre of travel, the load has only reached 260 kilos. The holding power continues to increase to 500 kilos after 2 metres and reaches its maximum of 550 kilos after 4 metres. There is severe soil disturbance with no real penetration. The 160 kilogram pool anchor behaves in a similar manner to the Danforth and drags for 1.5 metres, then stands up to begin burial. The load after 1 metre had reached 310 kilos and had increased to 980 kilos by the 2 metre mark. The maximum holding power of 1,180 kilograms was achieved after 3 metres. At this point, the anchor became unstable and began to roll out, resulting in a significant reduction in holding power. Again, there was a large amount of soil disturbance, but little or no discernible penetration. The 1-ton clump weight had reached a holding power of 850 kilograms after dragging for 1 metre, and this continues to increase to 1,155 kilos at 2 metres, then reaches its maximum of 1,310 kilograms after 3 metres. The holding power hovered between 1,200 and 1,285 kilograms until the test was stopped after 4 metres of drag. The soil disturbance is again significant, with no penetration. The 300 kilogram DMS 300 begins in the same manner as did the Danforth and Poole anchors. It drags with gradual build-up in holding power that reached 390 kilos after 1 metre. By the 2 metre mark, holding power has increased to 2,020 kilograms. But at this point, something quite spectacular occurs. The anchor stands up on its toes to begin burial. But instead of penetrating the soil, the load drops off. The anchor fails and the flukes collapse. The soil disturbance is considerable. Penetration is minimal and the anchor has failed structurally. The 25 kilogram Stingray anchor begins to penetrate immediately load is applied. The anchor has totally disappeared by the 1 metre mark, and holding power is already up to 1,155 kilograms. By 2 metres, it has reached 2,525 kilos. And after 3 metres, holding power has increased to 3,065 kilograms. The test was stopped at this point and penetration was measured. There was minimal soil disturbance and penetration was measured at 730 millimetres. The 25 kilogram Stingray anchor has safely held more than 3 tons. A 50 kilogram Stingray was also tested with similar startling results to the 25 kilogram model. Again, burial begins immediately the load is applied, with the holding power well above 1,000 kilograms after 1 metre and 3,180 kilograms after 2 metres. The test was stopped after 3 metres with a holding power of 5,020 kilograms achieved. Soil disturbance was again insignificant, while penetration was recorded as 910 millimetres. A 50 kilogram anchor has successfully and safely held more than 5 tons. From these results, it is clear that Stingray anchors are vastly superior to all other types tested. When taken to their ultimate capacity, Stingray anchors give efficiencies in excess of 200 to 1. Stingray anchors offer far more advantages than simply giving the best holding power. Stingray anchors set much faster than conventional anchors. The weight-saving advantage in terms of handling and installation is enormous. This is further enhanced by the Stingray's unique ability to fold flat for transportation, thereby offering huge savings in freight costs. Because of this, it is possible to fit many more Stingray anchors into the same space that would normally be taken up by a single conventional anchor. There are also potential savings to be made on boat time during installation. The anchors can be assembled by one person in a matter of seconds. Stingray anchors can also operate with uplift angles far in excess of conventional anchors. This translates to less ground chain, resulting in large savings being achieved. Freight costs are therefore also further reduced. The Stingray series of anchors has been developed by people with more than 100 years of experience in the design, manufacture and supply of quality mooring equipment and marine hardware. You can operate with total confidence in the Stingray anchor, as they are fully engineered and tested by a company with an international reputation for excellence and innovation.